Okay, so this is going to be video 2. In the first video, we looked at expanding logarithmic expressions to the addition and subtraction of multiple logarithms of the same base. And now what we're going to look at is condensing the addition and subtraction of logarithms of the same base into one logarithm. And so basically what we want to think is that this is the reverse process. So when we're expanding out, the first thing we want to do is to first simplify the expression within to make it basically the multiplication of bases raised to powers in the numerator and denominator, and then expand out the logarithm, right, into the addition of subtraction of logarithms, then throw the exponents out front and make the multiplication. When we're condensing, basically we're going to do that same process in reverse. So we're going to make multiplication exponents inside the logarithm first. So we're going to bring in that multiplication, make it exponents inside the logarithms, and then we will condense logarithms of the same base to one logarithm. Say 2, 1 log. And then once we've done that, we can talk about simplifying. So let's get involved in this process right here. We'll look at 2, and then I'll let you guys go through and do the rest of these. So right here, with this first logarithmic expression, we've got 2 log base 2 of 3 plus 5 log base 2 of x. So right here, my first step is going to be to take the multiplication out front and make it exponents inside these 2 log base 2s. So right here, I'm going to call this log base 2 of 3 squared, right? Bringing that multiplication inside and making an exponent, and then plus log base 2 of x to the 5th, right? So these are 2 positive logarithms, right? Which means when I condense them into one log base 2, I'm going to see the multiplication of the terms or the expressions inside these logarithms multiplied in the numerator. Since these 2 logarithms represent positive exponents, we're going to see what's inside of them multiplied in the numerator, right? So right here we would say that this is log base 2 of 3 squared, or I could call that 9. And then right here times x to the 5th. And these are equivalent statements, right? So right here, these are all equivalent statements. B is what I'm going to let you guys do on your own, and I'm going to look at D. I think B is more interesting for you guys to think about because what we're seeing here is 2 negative logarithms. So I'm going to let you guys do that on your own. Right here, we've got D is 2 times log base 4 of 5 minus 2 times log base 4 of 2x. So right here, my first step is to take the multiplications of 2's out front and bring them inside my logarithms and make them exponents. Right here, I've got log base 4 of 5 squared. And then right here, minus log base 4 of 2x squared. And I want to remember that that 2x is being squared, not just the x. So we're going to put parentheses around that. Okay, so now right here, the log base 4 of 2x squared is a negative logarithm, which means what's inside is going to be multiplied in the denominator, whereas log base 4 of 5 squared is a positive logarithm, so 5 is going to be multiplied in the numerator of our 1 log base 4. Right? So right here, we're going to have 5 squared, or 25, in the numerator, and then our 2x squared, or 4x squared, right, in the denominator, right? And that would be the condensing of that logarithmic expression. Oops. X. Well, come on, hands. All right, let's see if we can get that right. 25 over 4x squared. Okay, so would you guys pause the video and give the rest of these a shot, and we will look at them together in a second. All right, guys, so let's take a look at the rest of these. So with B, right here, we've got 2 negative logarithms. So after we bring that 3 inside and make it an exponent inside our first negative logarithm, when we condense, what we want to remember is that what's inside those negative logarithms is going to be multiplied in the denominator. So right here we see the 3 to the 3rd as 27 multiplied in the denominator, and then that 2 being multiplied in the denominator of our 1 common log, which is the condensation of these 3 common logs. So right here, 4x, since it's a positive logarithm, is going to be multiplied in the numerator, and then the things inside our negative logarithms multiplied in the denominator. And then in the end, what we're going to get when we simplify is 4x over 54. We could simplify that a little bit, I guess. We could call that the common log of 2x over 27 if we really wanted to get particular, but that's basically the condensation of these three common logs. Right here, looking at C, we've got the addition of two natural logs, right? And first what we want to do is take that multiplication of 2 and bring it inside and make it an exponent of 2. Now that exponent of 2 is applied to everything that's inside that natural log. So right here we're actually squaring 3x, which is going to give us 9x squared. And then when we condense these two natural logs to one logarithm, we will be multiplying in the numerator since they're both positive, and we'll get the natural log of 27x squared. Okay. Right here we've got the subtraction of two log base 4s, right? So a positive log base 4 and a negative log base 4. First thing we do is take that multiplication, those multiplications of 2, right? Oh, this actually, we just did this one, didn't we? My mistake, guys. You guys have seen this one already. Let's go ahead and look at these next 4. So right here, E, we've got 2 log base 2s, right? First thing we'll do is bring that multiplication out in front, inside, right? Make it an exponent. Again, what we want to think is everything that's inside that log base 2, both of these log base 2s, is being raised to those powers. So right here we've got xy cubed squared, right? And here we've got yz to the 5th, right? So right here we'll distribute the exponents to the things that we're multiplying inside these logarithms. And then we will condense this into one log base 2, right? In this one log base 2, we've got y to the 6th times y to the 5th, which is going to give us y to the 11th in the end when we simplify inside that logarithm. Okay, so right here we've got the subtraction of two common logs, a positive common log and a negative common log. We'll take that multiplication of 3 and make it an exponent inside our negative common log. And then right here, when we condense into one common log right here, what we'll see is what's inside the positive common log is multiplied in the numerator, what's inside the negative common log is multiplied in the denominator. And we can evaluate that exponent of 3 and call that 27. So last 2, right here we've got 3 natural logs, right? 2 positive natural logs and 1 negative natural log. So basically, after bringing in that multiplication of 2 and making an exponent inside our second positive natural log, we can condense these 3 logarithms into one natural log, right? The 2 things inside the positive logarithms will be multiplied in the numerator, and the thing inside the negative natural log will be a division, or something multiplied in the denominator. Right here we can say that 3x squared on our way is 9x squared. And then right here we can simplify this expression. We can multiply our 3 and our 9, giving us 27, and we can say that that division of x inside that natural log is going to cancel with one of the x's in the numerator that's being multiplied, and so we can call this the natural log of 27 when we condense, right? So right here, this last one, we're sort of seeing a big neon sign here. And right here, we can first say, if we look at this expression, we can at least bring this multiplication of 2 inside and make it an exponent, which will give us, which will give us 4x squared inside our log base 4, but then we cannot condense these into one logarithm because they do not have the same base, right? This is a log base 3, and this is a log base 4. So these two guys will not condense into one logarithm. Okay, so next page we are looking at condensing polynomial expressions with logarithms. Right here, this is again the same process that we saw, now in reverse. So right here, again, if we've got 2 logs of the same base and we're adding them, that means that we can represent this as one logarithm with the 2 expressions inside those logarithms being multiplied in the numerator, since we've got 2 positive logs. So right here I could call this 3 minus x times x, and then right here I could simplify this to log base 2 of 3x minus x squared. So looking at this guy, again right here, it's the same properties that we talked about before, and now we're just dealing with polynomial expressions inside those logarithms. So right here, I want you guys to go ahead and try these other 3, and we will look at them together in a second. All right, guys, so What we have here with b is the subtraction of two common logs, right? A positive common log and a negative common log that we're combining. The first thing that we're going to do is take that multiplication of 3, bring it inside and make it an exponent of 3. And then right here, I made a mistake. Right here, this is a subtraction, right? So with the subtraction, what we should see is the common log of x plus 1, and then right here divided by x cubed, right? And basically what we want to think is, of course, what's inside a negative log is going to be multiplied in the denominator. So my mistake there, guys. Okay. With c, we've got two positive natural logs and a negative natural log. So right here, what we can think is what's inside those positive natural logs, when we condense, will be multiplied in the numerator, and what's inside the negative natural log will be multiplied in the denominator. So we've got x squared times 3x multiplied in the numerator divided by x minus 2 in the denominator. And right here, that will give us the natural log of 3x cubed divided by x minus 2. Okay, so in this last expression, we've got a positive log base 4 and two negative log base 4s, right? So basically what we can think is this 5x, when we condense into 1 log base 4, will be multiplied in the numerator, and our x plus 1 and our x minus 5 will be multiplied in the denominator since they are inside negative logarithms. And right here, when we simplify this, we are going to get log base 4 of 5x divided by x squared minus 4x minus 5. Okay, so I'm going to break this up into 3 videos. We'll talk about change of base. This last video is going to be a quick one, though. So right here, we'll stop our video and we will go ahead and look at change of base and some things we can do with it in a second.